Hi, this is Ross, and this is the third video in a series of videos I did documenting a boat project, specifically customizing and updating the instrument panel on my boat. I added some engine instruments and did some, in addition to the instrument panel, did some custom panels using carbon fiber and Kevlar. So in the next couple videos, I think in the third and fourth, I'm going to try and slow it down a little and try and address if you're not exactly accomplished do-it-yourselfer, kind of go at a little slower pace. So if you are an accomplished do-it-yourselfer, you'll probably see a bunch of stuff that you already know, and you skip forward if you want. So, anyways, here goes.
One thing I did want to mention, if I did this right, and you want to see all my videos, you should be able to just go to YouTube and type in the Slipperlilly keyword, and hopefully it should bring up all my videos. So obviously, to get to this, a panel like this, you're going to be starting with a bare panel. Typically, it's most commonly it's probably going to be a piece of wood. Um, I use this stuff called Yucca board that I found at Home Depot. I liked it. If I had to do it again, I just use this for everything. Whatever you use, you just want to be sure the adhesion properties are going to be compatible with the epoxy you're using. Whether if you're using something that's been painted or a sheet of fiberglass, first and foremost, you want to make sure it's going to adhere to the epoxy that you're going to use. So in my case, I did have a failure to adhere that I want to kind of go over. My substrate, or in other words, my panels, since I was using black carbon fiber, I wanted the substrate to be black. So I just actually used some flat black spray paint, and I pretty much assume it would stick, and it actually did not. I learned that when I did cut out the holes, took the hole saw and cut out the holes for the instrument panels. And what you're looking at there, the discs I ended up with, the cutouts, that's one cutout. It came apart. The one on the left, that is the first coat of epoxy, the carbon fiber, and then the subsequent flood coats of epoxy. And the disc on the right is the substrate, the wood, and the paint. And as you can see, obviously, the first coat of epoxy did not stick to the paint. So here you'll see a close-up of the actual hole, and inside that circle there, you'll see a black line. That's delamination. Um, so given that this is just a cosmetic piece, and as you can see from the first coat of epoxy, the carbon fiber, the subsequent flood coats of epoxy, that's all good. And on top of that, the gauges themselves are going to help hold that layer to the substrate, the wood. So I'm really not worried about delamination. It's been a couple months and everything's still fine. There's absolutely no indication of any kind of problem. If this was a structural piece, however, complete opposite. You'd have real reason to be concerned. So again, this is why I want to stress: do your homework as far as compatibility with your materials and make sure they're all going to stick to each other. So here's a shot of the other two panels I did. The yellow Kevlar that replaced just a white plastic panel that was there, and then the black carbon fiber piece. That's a spacer I needed to put between the remote console and the side of the boat, just to add some clearance for the handle. Um, and again, the color of your substrate or your bare panel that is going to have maybe a nominal effect, or maybe even a little bigger effect on the shade of your finished product. Getting back to paint, I would just dispense with paint, eliminate that variable, whether it's going to adhere to not, or not. You can get colorants to add to your epoxy. I think probably, in my opinion, the best path is just to give your bare panel a good coat of epoxy with the color in it. And you'd want to do that front and back, seal it up really good. And then the other material I used for my bare substrate panels was this. As you can see, it's much lighter, and it was more compatible with the Kevlar. It's much easier to take a bright piece and darken it up than it is to take a dark piece and make it much lighter. Although I didn't really like this stuff too much. It was a little too light. It lacked density. It was a little too much like balsa wood. This is only about a quarter inch. Um, but you just got to kind of figure out what's going to work for you. So I didn't film it while I was actually doing it, so I just kind of went back and filmed going through the motions of making the substrate the blank panel for my side panel that you saw in the previous picture, the one made out of Kevlar. Yeah, that's not a pencil; it's a screwdriver. But I'm just pretending here. So if you'll note, what that is 2 layers of that Yucca board. That Yucca board's only about 1/8 of an inch thick, so I needed it thicker. So I laminated, glued 2 pieces together. Really important if you're going to laminate something. That's the first thing you do before you do any kind of cutout. Just get a couple pieces that are the approximate size and shape of the panel you're going to be making. Glue them together first, and then from there, what you'll do is you'll take your template, your shape that you're going to use, and then scribe around that and do your cutout. Then I just sand it. One thing you don't want are any shiny edges. That Yucca board has a kind of a sheen to it. You want to make sure you sand all that off. You want a rough edge. Um, then I'm just going around sanding the surface and the edges, obviously. So, and when you're done sanding, and basically prior to every application of any epoxy, you want to clean your work really well. I used acetone. Typically, I think acetone or denatured alcohol is the most common for this kind of work. I live in California, so where denatured alcohol is um, outlawed, it's like everything else that's fun. Anyways, so then what I did, since I had 2 yards of Kevlar, everything I did, I put a sheet of Kevlar on the backside, and that was mainly because I just wanted to encapsulate the whole piece, front and back, with an epoxy and a fabric. You could probably just accomplish the same thing with just epoxy. Give a give it a good coat of epoxy on the front and back. So this is just a quick look of doing the backside, putting that sheet of Kevlar on there. And don't be. I bought 2 yards of Kevlar because I was going to do two. I did do 2 sets of panels, one in carbon fiber and one in Kevlar. And I bought twice as much Kevlar as I needed. I bought twice as much epoxy as I needed just because I wanted to go big and just do a bunch of different stuff. You don't have to buy that much. They have actually kits available if you want to look into buying a kit that gives you just enough for each. I wanted enough to experiment and make mistakes and redo it. So that's the only reason. And so like I said, I had 2 yards of Kevlar. I got to use it up somewhere. It was either this or a bulletproof vest. So yeah, I don't think you got to be using Kevlar on your backside or even carbon fiber for that matter. Then what you need to do is just seal up bare wood. Bare wood in the ocean on a lake is like a sponge. It's going to absorb moisture, and so that's the reason for making sure it's all sealed up on the front side and the back side. As far as your supplies for mixing and applying, you're going to go through a lot of rubber gloves. I went through a lot of cheap paintbrushes. For mixing cups, I would get it. I was halfway through before it dawned on me to just go buy some good quality plastic cups, which was a heck of a lot cheaper. As you see there, I'm using that plastic mixing cup, typical mixing cup you can get at Home Depot. They're like $3 a piece. So I spent about $30 on those before it finally dawned on me that try some good quality plastic cups, and those work just as well for about 5 cents a piece. Um, so here you see that white stock panel that just came with the boat that I told you about. This is where the remote control bolts into, and then that black piece, that's a spacer piece that was added. Originally, the boat had a keyed ignition on the instrument panel, and then it was repowered, so it was rewired, and this spacer piece was added, which obviously, as you can see, is really ugly. So I wanted to rebuild that, make something different, but what I didn't have was a template. So what you can see here, you can see on the front there the masking tape. So what I did was kind of just mask out the shape of what I wanted, and then from there just take some tracing paper, trace it out, trace what you'd be doing in this case would be tracing the outer edge of the masking tape onto the tracing paper, and then don't cut it yet. Take the tracing paper with your penciled in outline of the shape that you want, glue it onto a piece of cardboard, and then once you've done that, now you've got your cardboard. That'll be your template, and cut that out to the shape. It'll be the shape that you want. and then that'll be your template to use to trace to whatever on the panel that you want to cut out for whatever you're making. So what you see there is there's my cardboard template for my spacer, and then I took that, and what I had done previously was laminated 3 layers of the Yucca board together because I needed something that was about a little over half an inch thick, and then I just took that, and that was my template. And one thing I want to add is if you don't have a lot of DIY experience, when you're doing things like this, allow for growth. So, for example, I took the Yucca board is an eighth of an inch thick. Um, Laminate 3 pieces together. What you're going to end up with is something a little bigger than 3/8 of an inch thick, and that's called basically growth. And you got to when you're doing anything like this, that's something you want to allow for. Just have in the back of your head that what you're going to end up with will probably be a little bigger, and that was fine in this case. It's not a big deal. And so the next thing I was touch on was whatever stage you're at in a project, make sure you're thinking ahead 1 or 2 steps. One of the things I wanted to be sure. So what I got here is I got the Kevlar panel, then the black carbon fiber panel, and the remote control. And my plan was, well, I'll through bolt the spacer panel to the Kevlar panel, and then the remote control is with thick wood screws screwed into the spacer panel. And what I wanted to be sure was that none of my, when I bolted the spacer panel into the Kevlar panel, I didn't want any of that to show. So here you got to plan ahead and make sure, spread it out so your remote control is going to cover up those bolts you're using to bolt your spacer panel to that Kevlar panel. And again, that's why I say, whatever stage you're at, plan ahead a couple steps because it's not going to come out good by accident. You got to plan it and make sure it comes out how you want it. So one exercise you're going to want to do at the very beginning, before you even buy anything, is what I did. I cut some discs out to simulate engine instruments on top of my original instrument panel, and just move them around, kind of just get an idea what gauges you're going to want to get, cut discs out to represent them, move them around on your instrument panel, because you're going to end up changing your mind about half a dozen times. I mean, this is basically represents a tachometer and then fuel gauge, water pressure, water oil pressure, blah, blah, blah. You may decide, well, let me go back. Maybe I'll just go with a tachometer and a speedometer. Maybe I'll just go with a multi-gauge. That's a single gauge that has a tachometer and big dial, and then smaller within the same circumference, a small fuel gauge and a small voltmeter. Um, so this is what you want to do to start with. Play around, get an idea of the instrument panel you want to end up with, and do that even before you buy any gauges. So obviously, at some point, you're going to need to transition from your original instrument panel, like this is my original shown here, to your new instrument panel with the new holes cut out for all your new gauges and the whatever the switches and whatnot. Point being, how and at which point do you do the layout for your new instrument panel, and then take a hole saw and drill to your shiny new instrument panel to cut out all the holes you'll need to install all your new gauges and switches. The way I did it initially was those are the 2 panels. One is the Kevlar, and one was going to be the carbon fiber. And I did the layout first. Then I drilled pilot holes, and then I proceeded to add my epoxy and my carbon fiber, and the layer after layer. And within each layer, I would re-drill the holes out. It ended up being a very silly way to do it. I there's yeah, don't do it that way. My original thought process was I didn't want to do the layout on top of my finished shiny brand new surface of the instrument panel. So I thought, well, I'll do the layout ahead of time. But that was silly, and it doesn't work out because ultimately, I would suggest it's what I did. You're going to want to wet sand and buff the surface anyways as the last step before installing your gauges. That's really the only way to get a nice, perfectly flat finish. It's how they get cars. That's when you look at a nice car, show car with a perfect paint job. That's how it looked. They got it to look perfect. They wet sand it and then buff it. Um, Obviously, I'm sure there's several ways you could go about it. So I'm just going to go over the way I ended up doing it, which was a combination of this having the pre-layout done when just re-drilling the pilot holes, and also using my existing instrument panel, the old one, as a template for drilling out the holes for the toggle switches and the circuit breaker buttons. So obviously a good way to do it is just do two cutouts of your instrument panel, identical cutouts. One is going to be your carbon fiber epoxy panel itself, and the other you'll use to scribe onto your layout, drill your pilot holes on. That'll be your template. And then when you're all done with your epoxy carbon fiber layup, clamp your template on top of your panel and just transfer the pilot holes onto your instrument panel. Making a pattern, or basically a little paper disc, for each of the instrument holes you'll need to cut out is pretty easy. Each instrument, the instructions will tell you what size hole you're going to need to cut out of your instrument panel. Basically, what I did was just take a Draftsman compass. There's a pinpoint on one end and a pencil lead on the other. I just set it at the radius of the hole I'm going to need, make a circle. Then you kind of turn it and take the needle point of the compass, set it on the edge of the circle, make an arc, set it on the opposite edge, make another arc. Where those two arcs intersect, that's going to be the center of your circle. Hence, that'll be the point where your pilot hole will be. And once you got all your pieces cut out, you'll be at this stage. And the next you're going to want to do, you're going to want to either glue them or tape them, but you definitely want to fix them to your panel before you start drilling, obviously. Otherwise, they're all going to move around on you. But you'll want to tape them or glue them down and then drill out your pilot holes. For pilot holes, I like to start with a small bit, something small enough that you can place it on your dot and actually push it into the wood a little before you turn the drill. That'll affix it to that very point. And that's why I say start with a small bit first. If you start with too large a one and you instead of pushing it into the wood, you just hit the drill button, it could spin off your mark and throw your hole off. And then from there, once you got a tiny hole, you can make it a little bigger if you want. I stuck with about a 1/16 of an inch, no bigger than an eighth of an inch. The size of your pilot hole is basically a function of ultimately the size of the drill that you're going to use. So, for example, here's a picture of a hole saw, typical hole saw you'll probably use, and in the center of the hole saw is it's about a 1/4 inch drill bit, maybe a little bigger. And you want your pilot hole just big enough for the very center of that drill bit to sink into and start the hole exactly where you want it. From that point, you want the drill bit in the center of the hole saw to create its own hole, so it'll be more firmly embedded in your wood, because that's what's going to guide and stabilize your hole saw once it starts cutting. So here's a shot of my panel as I was getting ready to drilling the holes for the gauges and whatnot. So for the instrument, for the gauge holes, I pretty much did them exactly like I just went over. But as far as the toggle switch holes and the holes for the circuit breaker buttons, my old panel's made of metal. So I just decided, even though I'd done the layout for them, I just took the old panel, clamped it on top of the new one, and used that as a template to drill out the holes for the toggle switches, the circuit breaker buttons, and the holes around the edge for mounting it onto the boat.
So that's it for this video. If you got any questions or comments, feel free to leave them in the comments section. I'll be checking it periodically, um, just to see if anybody's even watching these out of curiosity more than anything else. But again, yeah, thanks